so that we finish very fast. We had reached a point where we are talking about the basic testing techniques. And Ibrahim, I didn't see Ibrahim responding on the discussion. Ibrahim, is Ibrahim still here ama amemute akaenda? Ibrahim,
Yes.
I didn't see you participate in the
Yes.
discussion. You didn't participate in the discussion. Where did you go?
Mwalimu
Yes?
nimejua venye ina mtu anaingia. Mtu anaingia.
Oh, okay. Unafanyaje unaingia normal class? Ibrahim.
Hadi huko discussion.
Na
ingia. Yes.
Sikupati kabisa. Hmm? Ibrahim, can you write on the public chat because I'm not getting you.
Hello?
Yes? Write on the public chat because I cannot get you. Finish the topic. Now on the basic testing method. And when we talk about the testing techniques, we have the tools or the instruments that we use in the testing process. The first tool is the multimeter. It's a very important tool. Once you have determined the most probably cause of the fault, you must either prove it to be the problem or not. This can sometimes be done by careful inspection, but in many cases, the fault will be such that you cannot identify the problem component by observation and analysis alone. So here the instruments can be used to help narrow out the problem and component. So we have now the general meter rules. Okay, we proceed. We have the general meter rules. There are many types of test instruments used for troubleshooting. Some are specialized instruments designed to measure various behaviors or specific equipment. There are other types of test instruments, such as multimeters, which are more general in nature and can be used for most electrical measurements. A typical multimeter can measure AC, DC voltages, resistance, and current. You can see those meters. Those are the meter precautions. What are the precautions when using the meter? Here are some of the do's and the don'ts. Be familiar with its features. You have to know how it works, and then read the instructions manual before using. Ensure it is safe to use. No obvious damage to the meter or the meter leads. Then be sure that the test leads are in the correct socket, and then the rotary switch is in the correct position for the desired measurement. Then never measure resistance in a in a circuit when power is applied. Never apply more than the rated volume between when any input jack and ground. Keep your fingers behind the finger guards on the test probe when making the measurements. And again, avoid false reading, which would lead to possible for personal injury. So those are ways of how to use the meter properly. Then we have the testing of live versus dead. How do we test? One of the first thing you must decide is whether the circuit can be live or must be dead while testing. So performing certain tests while a circuit is live can be very helpful. However, some companies have policies that ban or restrict testing live circuits while troubleshooting. So before doing any testing, make sure you check your company's policy. This module does not contain that. Then we proceed types of faults. You can now see faults can generally be categorized in either open circuit or short circuit. This is now a generalized type of faults when testing the meters. The open circuit occur when there is a break in the circuit. This would be broken wire, loose connection, or burned components, etc. And then the short circuit occurs when two or more components, which should be isolated, come in contact. Now, like two wires, one live and one neutral wire, when they come into contact, then they become short circuited. So this is an example of a short circuit, and this one is an open circuit. An open circuit means that the circuit is not complete, while a short circuit means that two wires that need not to meet at a point. The sectional circuits and meters. Sometimes you will be faced with the problem that there are a few useful observations and the problems area in the large portions of the circuit. It may not be feasible to begin testing all the components in the problem area. You should now still start with the component you identified as the most probable cause. Then you look at the problem. Now, using a voltmeter. How do you use a voltmeter? The voltmeter is the best tool to use in finding the open circuit. If you can if you can safely turn the power on. Now, once you know it is open circuit and have determined the general area of the fault, then get your voltmeter out and check that it's working in a known source. So connect the negative lead the known reference. You can see now there the known to the known reference, and then the negative neutral to the ground of the AC supply, which is preferable. Then test through the affected circuit with the wire device between the last point of testing full voltages. Now, do not forget about checking the neutral path. When you get full voltage at the position terminal of the device that is supposed to be operating and isn't, don't stop. Carry it through and return the path, the negative or neutral. So this wire is open. You realize that this wire is open after testing using the voltmeter. Then using an ohmmeter. An ohmmeter is mostly used to test the resistance. So when using an ohmmeter, you must first shut off or lock out the power supply. Using using a connection wiring diagram, determine the location and component which you feel the most probable cause. Now then next disconnect the wire from the component are which will eliminate possible parallel paths. Then you should be careful to identify any wires to disconnect. And then we go on and talk about using a voltmeter on to find short circuits. You can also use a voltmeter to find short circuits. Short circuits allow voltages and currents to flow in the wrong parts of the circuit, so which causes malfunctions. These tend to be easier to find with an ohmmeter. The most common type of short circuit is a short to ground. To find this type of fault, first lock out the circuit, next disconnect and remove the wire. You can now see there. Using an ohmmeter, find an open circuit. Now that is the procedure. I'll give you these notes so that you can be able to look at them. Find the type of fault, that is first lock out the circuit, next disconnect and remove the wire and the component. you have identified as your most probable cause. Then connect one lead of the ohmmeter to the ground point and the other lead of the suspected component. So that is how to check it out. Then next we go to an ammeter. An ammeter is supposed to check current. An ammeter, you can measure the current flowing through a circuit. This can be very useful when you where other test instruments, voltmeter and ohmmeter, are not appropriate. So, for example, measure the current in each of the three phases can provide very important clues of them. There are two ways to use the ammeter. First way is to connect the meter into the appropriate socket of the meter. Then insert the meter into the cap. You can now see how it is connected. You can now see how you can test the current. Then you connect the live wires. The next is now these are revision questions. You will go through them and you can know how to troubleshooting basic technique diagrams. These are some of the diagrams for troubleshooting and wiring diagrams. The basic methods of fault finding diagnosis. We have synopsis chart method, we have algorithm chart method, and we have functional chart method. There are normally different charts that are used during the diagnosis. Form of synopsis chart provide a convenient way for a plant or equipment supplier to convey the user's acquired experience about the common faults. Synopsis is maybe what we normally have. Now, like construction of synopsis chart, now detail of each symptom, including the these are now the procedures, the nature of the check to be made, expected results, and the remedial action. So now you can make a chart and know that what are the answers. Now, like now, the chart, you know the fault, you identify this symptom that is you identify the cause, then the cause, and then you repair that. And then we have another one that's shown below. Now these are reports of the chart. Now what was obtained. Algorithm charts are the ones that say yes or no charts, like the ones that we had that has a flow chart. You can see now it is there. That is when you get this. If it is yes, then you proceed and do this. If it is no, you do this. So these are the advantages and disadvantages of algorithm charts. They can be used to advantage the maintenance of the personnel. Okay, I'm talking about the advantages and disadvantages of the algorithm chart. They can be used to advantage by maintenance personnel who are not familiar with the basic logic the system, but are competent to carry out specific tests and make observations in accordance with defined instructions. The algorithm charts can often lead to maintenance more quickly and logically towards the fault area than, than would a symptom chart. Now, the algorithm chart generally fall and teach the maintainer how the system works. Think about how the system. Now we have a structured functional block diagram of how you can track the control signals. So once you go through them, hold of this. Test information, this is now a report. After you've already tested, you have to know now, you have to put down a report and get the flow and control, maybe what was happening and what you found out during the test. These are now diagrams, the wiring diagrams and the schematic diagrams of the test cycle of all what you are testing. Those are skill charts, downtime and repair time, that is not scheduling, of time, alignment time, logistic time. You have to record all those. So they are very important. Checking restoration. Now after you have already checked, you troubleshooted and found a problem. Now what do? You have to restore. That is now called the field or workshop repair. So that process is a troubleshoot as a troubleshooter. At some point or other, you will have to decide whether to send components to the workshop or repair or for repair as opposed to carrying out repairs on site. So sometimes such decision is simple. For example, The work cannot be done on site or special transport may not be advisable in the acceptable time. So the following are factors that should be taken into account when making availability of the resources you have to check, and that is the workshop equipment and transport. Also the cost of the workshop time, the transport cost, and the time loss in production process, the expertise availability, the availability of stores and parts, and many others, and accommodation if they need to be a sleepover. Then the short-term repair, these are repairs that can be done. First, we consider to decide whether, but the short-term repair should include the following: safety legal requirements should be violated, system integrity should be maintained. So that is how these things should be done. And then repair and replace. You said that when you have already done all the analysis, you've done the fault finding, you've already found the fault. Now you need to repair or to replace the worn out equipment. Fault conditioning reporting, that is a reporting, you'll be able to see those notes. And then there are discussion questions there, and that becomes the last slide, and we are done with that. So I've already posted these notes in your portal, and I'm going to generate an assignment for you. So next week you'll be able to access the assignment. Next week our lesson will be very short because we will be also needed to give out the assignment. So I want to hear maybe any comments or questions before we can finish the lesson. I want to hear questions from you guys. Can I hear people speak? Salad, Ibrahim, Salad said the mic has a problem. Ibrahim, you can even write the questions on the public chat so that I can see them. Ibrahim, Salad will help you to know how to join the discussion so that you can go and make your comments on the discussions that we had today.